Hey everybody, we've got another video for you today, and this one is based on a shop repair. This isn't a customer thing, something actually in my shop broke. So I've got my milling machine over here that you've seen in some of the videos. This one is the one I use primarily. I've got another one over there I just don't use very often. It stays set up for a particular purpose, and it gets used when it's needed. But in this one, the centralized oiler, it's got a lever that you pull to oil the milling machine. And I do that, pretty much every day at least, maybe a little bit more often, depending on how much work is going on. But the lever broke off. And it's a cast metal part. So there's not really much I can do to repair it. We're just gonna go make a new one. So I'm gonna take the camera and get it over to the milling machine and show you what broke. And then we'll come back to the bench and we'll start describing the project and what we're gonna do. So here's the mill I was speaking of. This is my primary mill. I use it for most of the work. And it has a central oiler down here on the bottom. Okay. This is the part that broke. There's a cap here that was the white metal that this was pinned into, this lever, and you would pump this lever to pump oil through these lines throughout the milling machine. So this broke last time I was using the machine, and without it, I honestly can't oil a lot of the places because where you normally would put oil in now has these fittings from these lines, so I kind of have to fix this before I can really use the machine for much. It was oiled immediately before it broke off in this last round, so it should be sufficiently oiled for this next bit of work, but I wouldn't really want to push it any further. Okay, so we've got our oil pump off the milling machine, and I can see in here that the O-rings I was curious about are indeed present, so we don't need to worry about that. It was a lot easier to look at here, and it only took 4 small screws to get it off, so why not? So there's our pump. We'll put that aside. What broke was this piece. And this screwed to the bottom of the pump and held the lever in place as I put my hands in front of the camera so you can't see a thing. But that lever was held in by a pin, and when you push the lever, it'd push on a piston which would pump the oil. So we need to replace this part. It's cast metal. I don't know what it is. It's non-ferrous. I'm not even going to worry about the numerous ways we could attempt to fix this. We'll just make a new one. Okay. I was hoping to make it out of aluminum. My local metal supplier is a welding supply shop. They have very little aluminum. The aluminum I had in stock was slightly too small, so unfortunately, I got to do overkill and make it out of steel. So here we are with our material in the lathe, and we start out by facing the end, as is tradition. Thank you, Blondie Hacks. I can't get that out of my head. And we're going to turn down the outside diameter just to get a uniform surface so we can measure and put an initial reading into the DRO. So now we got this in our DRO, and we're going to begin turning down the outside diameter to equal the outside diameter of the component we're replacing. So another measurement just to be sure we're on track, dial in our last little bit of cut, and this should take us to the final dimension for our part. So we'll take a look here. We turn down, stop the machine, and check our part. Perfect fit. Okay, here we are back in the machine, and we have blued this, and all I'm doing now is measuring from the end, and I'm going to put a witness mark at the max height of the part that I want to create. That way I'm just sure that I don't accidentally take off too much during anything that I'm doing on the lathe here. So we're just going to touch, and there we go. Okay, and now that we've got our dimensions marked, we're just going to move our apron over and back our cross slide out of the way to start our drilling and boring operation. Okay, and here we come in with our center drill. I know I should be using a spot drill, but I'm using a center drill just like pretty much every single other person that I know. So we're going to go ahead and just drill our starting point. There we go. And we're going to be doing this in multiple steps like you traditionally would, but we're going to start off in the very beginning with a split point drill bit. It's a 1/4 inch, so we're going to be able to go in the complete depth that we need with that split point and then use the larger drill to take out the bulk of the material. Okay, here we go. We're bringing our drill in. We're going to go ahead and get lined up and clear off a little bit of the material there. And what I'm going to do is, these measurements aren't precise, but they got to be close enough. So we're just going to use a little piece of paper in front of the drill bit to mark where the drill bit is just, basically at the level of the hole. And we just have to go in a hair over our total depth so that when we face off the opposite side, we have a complete through hole. There we go. The paper's dragging on the drill bit. I know I'm within about, probably 3 thou of the surface there, probably a little more. I wasn't being super accurate, but it was close enough. And I know that I have to drill into there basically 2 inches. So that's far enough to take me past the total height of my part.
So here we go, drilling our first hole. That'll be our pilot for the larger drill bit, and we've switched over to our larger bit, doing the same thing with the paper, doing the alignment so I can measure on the tailstock, and drilling out our first larger hole. I'm going to switch to the largest drill bit I have here, which is I believe 1.25 inches. And as you can see, my drill bit definitely is in need of sharpening. It's doing significantly larger chips on one side than the other, which is a good indicator that your drill bit is not sharpened evenly. The length of the cutting flutes are basically not the same on both sides. And here we go with the boring bar, and we're just basically going to bore this to our interior dimension and then cut a seat for the protrusion on the oil pump. Okay, so I've sped this up significantly to save you from this rather boring operation. And in the next section here, we're basically going to just double check our diameter. Okay, we look like we're the right diameter, double check our part. Yep, everything's good. So we've changed tools, and now we're basically going to put a witness mark for how big that remaining flange needs to be. So we're going to go through here and checking the thickness of our part, checking here, and we'll just turn down our mark. And there we go, turn down to a secondary diameter, and now we're going to cut the seat. That secondary diameter was nothing more than just a little bit of clearance space for when we get over to the mill. Okay, we'll just check our 0 there, and yeah, here we go. Cut our seat to the correct depth, and just chip away at the edge. There we go, just double check our dimensions. Make a few final little small cuts, and that feature is all set.
Okay, so here we're at the mill with our part we just took off the lathe. As you can see, we've created this internal recess right here, and we've bored this to more than what we need, because what's going to basically happen is, obviously this is the bottom. Let's turn this over to match these up, and we're going to need to cut these top features. So we've got a nice flat bottom in here. Right? And we've got to cut our top features in here, this pin, locating a few of the things. And as I said, we're not going to recreate this completely. These are going to basically come straight across instead of this supporting rib. Since we're using steel, I don't need this supporting rib through here. So we're going to go, obviously, cut the groove, cut the flats on either side. We'll have to cross drill for the hole, and of course locate our 3 bolt holes. And that really should be about it. So the very first thing we're going to do is pop this bad boy here into the mill and deck this surface off. I made a couple witness marks over on the lathe, and these were just reminders for me that, as you can see, let me see if I can hold this with both hands. This was nothing more than to make sure that while machining I left enough material. And you can see we've got a little bit of a radius would have to come up here, but this line was my minimum line. So all this here is material I can work with to go ahead and take this down to the finished profile. So let's go ahead and get it in the vise. We'll deck it off, and we'll start cutting some features. Okay, so you can notice a difference here. I went back over to the lathe, and I cut off that extra little bit that we had. It's just material we're going to mill off, and it was faster to take it off on the lathe than it was to do multiple passes with the end mill. So we did that, and also where the remaining blue was, it was actually a little bit larger diameter there, because obviously I hadn't turned that section down, and what was happening is the upper portion was catching on the jaws and causing it to tilt just a little bit, probably just a thou or two, not much, but what that really meant is that I was only gripping on a very small portion of this piece, and when we get done, we're only going to have this much of the bottom left. You know, it's very, very small down there, and I want to have as much material as possible to grip on. When I have to add the V-block to make sure this is stable and a few other things, I really run out of material quickly. So what I'm going to do is I'm going to put this back in the V-block like it was. And then I think we're going to cut the center groove through, just passing through. And then we're going to cut the left and rights, but not all the way to the edges. So I'm going to end up having a groove, and a groove. But then I'll be able to raise this part up and just take those grooves off very easily without a lot of force. What I'm really worried about is if it's sitting up in the vise with, you know, only a 1/4 inch to hold, and I'm trying to do all those passes to cut those features in there. I'm just worried about it wanting to kick out of the vise. So allowing it to sit deeper in the vise, and now we'll be able to take those grooves And the biggest reason I can't go all the way to the edge is on this side. You know, we'd be right up against the jaw, and I could put some soft jaws, we could do some other stuff. I just don't have that here, and I don't want to set it up. But on the other side, where we have the V-block at, so the V-block actually, when you're in here, actually be easier to show you on the camera this way. So because the V-block is tangential to 2 points on the circumference, that means that if I were to try and cut right up to this edge, I'd be cutting into my V-block. Now this is just a cheapo mild steel V-block I made, and it's not that big of a deal, and I could do that, but I'd rather not. So I think being able to cut the center out and then the 2 slots to define the edges of that center portion and make sure that they're parallel and straight and even. Then when I take it out, it'll give me some play. You know, there'll be some room between what I need to remove and the slot that I cut. That way I don't have to worry so much about if I'm off by just a degree or so when I go to take that extra material off. So it'll probably make more sense when it's set up. But let me get this going and I'll show you what we're going to do. Okay, so I've got my part setting in here, and this is just temporary. What I've done is I've taken out the V-block, and now this is just grabbed between the jaws. And what I'm going to do is I'm just using this to set my DRO. So we'll keep this back wall against the fixed jaw, and we'll be able to measure our half distance between here. It's a little easier. You know, I could do a bunch of other measurements, center, whatever. But I'll just measure off these 2 jaws, center up, and then I'll be in the middle to make my cut. Okay, we're currently centered on the part off the back jaw. Okay. So what we're going to do is we're going to loosen this and put our V-block in the front to hold the part, but that will still maintain our center position.
All right, here we go. Get our V-block placed back in, tap our part down, and change out our tool for our first cutter. So this cutter is actually smaller than the center groove that we need to cut, and here I'm just indicating the top of this part. So I can basically set my depth, and I set my depth stop up on the mill, so I'm going to come down to the same floor every time. Okay, tap down, tighten, and make our first cuts. So what we're going to do is cut through the center of this piece, and then clean up left and right of this center slot. So I'm just going to go put my initial marks in, and it's oftentimes a lot faster if you're going to essentially drill your way down. Now unfortunately, this one is not a center cutting end mill, so I can only go over in steps the distance of 1 tooth, you know, however deep it may be. But it's much, much faster this way than it is going straight across for bulk material removal. So we go through and basically drilling these out, and then we're going to come back and straighten up our sides right after that. Boy, it was getting hot in there too. That oil was smoking. So there we go. Now we've cleaned our floor, and now we're just going to come over and trim each side to the proper dimension. Here we go. And we're doing that in a few passes because we want to have a nice clean finish. The left edge is the edge that's actually going to become the pivot point for our lever when it goes in. So that one is the one that is most critical, but of course since we're cutting across the center, all things are even. And there you saw we just tested our pivot point just to make sure we fit. So now I've swapped out to a 1/4 inch carbide end mill, and we're doing that same process. We're cutting a groove all the way through, and this groove establishes the width of the ears that will hold the lever. So all this groove is for is when I turn the part for later cleanup operations, that I don't have to worry about accidentally hitting the ears that I've created or worry about critical dimensions or critical measurements. Doing all the criticality here in a single setup to make sure that I don't have to worry about remeasuring, re-indicating, and keeping everything parallel and square to its relative surfaces. So we're going to cut that one, and then we'll come back over to the other side and basically just repeat that entire process. And this carbide end mill is making quick work of this. It is obviously sped up here on film, but it did make a considerably faster cut than my high-speed steel that I was using. I think that original high-speed steel might be a little dull by now. I'm going to have to take a look at it. I usually use it for you know, the side milling of things. I don't usually use the end mill of that high-speed steel one very often. All right, so here we go, just cutting our other slot. And you'll see we'll come up onto the end of that in just a moment here and get the ability to take a look at our part. So now what I'm doing is basically setting the depth of those ears from the center circle to the outer perimeter of our part, and we're just going to trim those down again while we're here to keep things perpendicular and square, and of course the proper depth all the way down on our cut. Okay, and here we go. Make a few little cleanup passes on those mounting ears. And since we're in here with this nice sharp carbide, we're just going to go ahead and start chewing away at some of that remaining material. A little faster than just changing the end mill. I'm sure the larger end mill would have eaten it up a lot faster, but this carbide was making quick work of it, so I wasn't too concerned.
Okay, so here's our part. And as you can see, we cut the center slot to the width of the handle and just continued that cut through to remove the excess material. And then we cut a slot on either side just to give us some clearance so that when we go to remove this remaining material, we don't accidentally cut into one of our important dimensions here. The outside of these isn't really that critically important. They need to be thick enough to support the pin. That's about it. But that's pretty good. So what we're going to do is put this back in the mill, and we're going to put it in this orientation now and be able to clamp on this bottom area. And we'll be able to remove the material all the way up here. Then when we want to remove this last little bit, we'll just flip it over, put a piece of material in here to push against the rear jaw and remove those last little bits. But everything's going to be referenced again off this back wall, and we're going to put in the fat end mill for doing this. So let me get this set up, and we'll go through that operation next.
So unfortunately, I lost a little bit of footage, but all it really was is the cleanup pass with this end mill. You can see where that other rough material has been removed, and this is just the final little bit on the outer ear pieces.
Okay, so here's our part just off the mill, and we cut off all that excess material, resurfaced everything to be uniform all throughout, and then just hit it with a little Scotch-Brite just to get an idea of how the finish was looking. I didn't care too much just yet because we're going to put it back in the vise, so why spend that much time finishing? Okay, so we've got our part upside down in the vise, and what I did over at the bench is I laid the original part and this part flat on the table, and I took some parallels to align them, turned them over, and I put a witness mark here, just so I can tell where I'm indexed correctly. Because what we're going to do is we're just going to eyeball these holes. The actual alignment is the internal edge here. This cup is what aligns this piece. These are just screw holes, just pass-throughs. So as long as the screws can pass through and hit the holes while it's on the hub, that's enough. So we're going to line up our witness mark. We're going to line up the edges of our part. We got our V-block over here, so we can butt up against that, and then just rotate until our witness mark is in location, and then just eyeball and drill the holes. So we'll drill one hole, and we'll drop a bolt in as a locator pin. We'll drill another hole, drop a bolt in as a locator pin to then fix that in place. Then we'll go drill the third hole. So pretty straightforward. Of course, we're not going to drill through this because this is exactly sized for this. This piece would just go flying. We're just using this to get our location, and then we'll drill and back and forth, and you'll see what I'm talking about. All right, there we go. We'll go deburr those in just a second here, but let's just take a quick peek and see how we did. Alignment hole, and alignment. Look at that. Perfect, quick and easy. Okay, so here we are set up to drill the through hole for a roll pin that holds the handle in place. And what I've done is the most parallel surface in here, the first thing I cut was this interior piece right here. So I've got a parallel that fits in there. This is pressed firmly against the parallel, which is on 2 1 2 3 blocks, to make sure that we're in a flat, even plane from the pivot perspective of the handle. Even if these outer surfaces were a little off, I need to make sure the pin goes straight through. So we've got this clamped in here, it's all tight. I've marked it on the bench, it's 85 up and 30 from the inner edge. So we're just going to go through and drill our roll pin hole. All right, here's our original broken piece, as you can see. And here's our new part that we've created. Finish came out quite nice, functions good. The arm moves smoothly, we're all set. As you can see, I've already pinned this in. But what I was going to do is round these corners, and I decided not to, and it was strictly an aesthetic reason. This side rounded probably would have looked quite nice, but because I have a curve on this side, if I were to get an even round over here, I'd have to eat into the larger side of the curve very close to the screw hole, and it would have made for a very odd and unusual transition. And I couldn't get any concept where I thought it would look good. So it actually looks better this way to me, so I just left that. So now all that's really left is assembly here, and it's rather straightforward. So we take our oiler, spring, and piston. Make sure our piston's nice and clean. Don't want any garbage or debris in there. Okay. Piston goes in, give it a seat home. Okay. It's a little difficult to do here, but it's quite a bit of spring pressure pushing that piston back up when I'm trying to hold it in. So we're going to go in here and put our lever on and push the whole thing down to get a screw in. Okay, there's one. Two, and the third one will go in significantly easier now. There we go. Just get these tightened down. Tighten them in rotation so it seats evenly all the way around. There is a rubber seal back there, so we want to make sure that we get evenly seated. Screw holes lined up nicely. Didn't have anything off, so that was great to see. Usually using that location method I did of lining up the old part with the new part is accurate enough for things like this. Mounting plates, you know, things of that nature that really just need a clearance hole for a bolt or a screw to go through. Nice and snug, nice and snug. And once more nice and snug. Here we go. Okay, I'm going to actuate the lever, which I might regret because there's probably oil in here. But let's just go and see. Yeah, lever action is working perfect, just like it should. All right, so now we'll put the dust cover on. Went on a little crooked, sorry. There we go. Okay, dust cover installed. Great. Go ahead and put this back on the machine, and we are good to go. That completes the entire thing. Hope you enjoyed the video, and thank you for watching.